Okay, today we're looking at sampling percentages. We're talking about, if we're doing a statistical study, talking about the sample, the percentages that we get from the sample, and ultimately making inferences about that entire population. Now, I've mentioned population and sample. Now, these are two very, very different things. What class do you normally hear population? Connor? Usually you think about social studies. What does it mean in social studies class? All right? How many people are in a certain area? And that's a perfect example. And it's pretty much the same thing when we're talking about statistics. There's a a very, very slight difference though for population or statistics population versus social studies class population. When we talk about a population in statistics, in math class, okay, what we really, really want is, very simply put, a group to be studied or analyzed. Okay, it could be a group of people, could be anything really. It could be a number of tests that I'm looking at. It could be, you talk about in the medical field, you talk about sampling, a population of drug trials, okay, trying to see what medications work. Now that's the entire population, the entire group that they want to study. Well, here's the problem with that. Let's say my population that I want to study is the entire student body of Brentwood Middle High School, and I want to know something about all of you. I want to know maybe what cell phone provider you use. I do not have time to ask all 700 to 800 people in this school what phone carrier they use. So what I do instead is I ask what's called a sample. Now a sample is a subgroup of the population that is surveyed about a topic. Now what we hope though, we really, really hope, is that this population, this sample I mean, is random. We really, really, really want them to be random. Now we'll talk a little bit more about what it means for a sample to be random later. For right now, I just want you to know that random in statistics means something slightly different than what you're used to random meaning in general conversation. It does mean something just a little bit different. Okay, we'll talk about that later on. Okay, now, percentages. Percentages, guys, they are wonderful. They are great for conversation, great for description, great for explaining things, but not super great for math. Okay? First off, let's talk for a second about how we find those percentages. When we were doing the starter, how did we find those percentages? How do we find the percentage for Riley's free throw attempts, for the students having a spare pencil, for the percent of students in the class that scored 100%? How did we find those? Kirsten, what did we do to find those percentages? Good, we divided success. We divide success by trials. Okay, the number of free throws that Riley made divided by the number of shots that he took. The number of students that scored 100% on the quiz divided by the number of people who took the quiz. Okay, and that gives us the percent in decimal form. Well, how do I go from percent to decimal? Or how do I go from decimal to percent? Very good. Decimal times 100 equals percent. What if I want to go the other way? What if I want to know if I have the percent and I want to turn it into a decimal? Bless you. What do I do then? Greg? Very good. Because here's the deal, guys. Percents, they're great for conversation. They're great for description. If I tell you that 50% of the students in the school use AT&T as their cell phone provider, you have a good idea of what that means. If I say 75% of the students in the school are participating in some sort of extracurricular activity, you have a good grasp of what that means. That's most of the students. But if I want to know how many of the students, based on that 75%, participate in an extracurricular activity, well, then that 75% is not so good to us. We would need to adjust it. We would need to turn it into a decimal. And that's how we're going to come up with these answers. Now, guys, we're going to have to use our brains. Okay, this is not a step-by-step process of how to answer these questions. We're going to need to think about it. This is going to help us, but it's not going to tell us exactly what to do. Okay, so let's look at the examples. Let's try to answer these questions. Okay, so a survey asked 40 people whether they liked Mac, Windows, or Android operating systems. 24 people chose Windows, 12 chose Mac, and 4 people chose Android. What percentage of the sample chose each operating system? So what we want here is we actually want the percentage. Like we said, it's great for conversation, it's great for description. So sometimes it's helpful to have that percentage. So what we're going to do, guys, is we're going to set up a little chart. And that chart is going to have a row for each operating system. Okay, so I'll have a row for Mac, I'll have a row for Windows, and I'll have a row for Android. Now, what I'll also have is a column for the number of people that prefer each system, I'll have a column for the decimal, and I'll have a column for the percent. Okay, and this is a good way to organize the data so that we can answer those questions. It's not necessarily the only way to do it, but it's a good way to see what you're doing. So let's start with this. The number of people that chose Windows was 24. The number of people that chose Mac was 12. And the number of people who chose Android was 4. Now, I want the decimal for how much of my sample chose each one of those operating systems. So what we do, like we said at the very, very beginning, we take the number of successes divided by the number of trials. Well, if I'm talking about Windows, these 24 people that chose Windows, that would be my number of successes. So I would take 24 and divide it by the number of trials. Well, what would be the number of trials in this case? What would be the number of trials here, Megan? Why 40? Very good. That's how many people we asked. That's the number of people in our sample. Okay, so we take 24 divided by 40. And what decimal do we get? Oh, Flanagan? 0.6. Now, I want to know what percent that is. Okay, there's two ways to do it. Option number one, we can slide that decimal point 2 spots to the right. Okay, that's one way to do it. That can be confusing for some students. So what's the other option? What did we say above that we could do here? What did we say, Kira? Multiply it by 100. So take that 0.6, use the calculator if you need to, but multiply it by 100, and what percent do you get? 60%. So that means that of our sample, 60% chose Windows. Let's do the same thing for Mac. Okay, let's take Well, how would I do that for Mac? How would I find decimal for Mac? AJ? 12 divided by 40. And what decimal will that give me? 0.3. Okay. Now how about the percent? How would I go from that decimal to that percent, Alyssa? 0.3 times 100, and what do you get? 30%. Okay, what about Android? How am I going to answer the same questions about Android? I'll give you a hint. The same questions. Logan, what are we going to do? Good. Divide 4 by 40. And what decimal does that give us? 0.1. Okay, now the 0.1, the decimal, that's going to be really, really good for doing our calculations, but it's not what we want. Okay, our final answer is we want what percentage. So finish it off, Logan. What do? So we take that 0.1, multiply by 100, and what do we get? 10%. So our final answer to this question, what percentage chose each operating system, is right here. Okay, that's the percent that chose each operating system. Okay, take a time out. Okay, number 2 asks, a second study asked 60 people the same question. It showed that 55% prefer Windows, 30% prefer Mac, and 15% prefer Android. How many people from this study chose each option? So this time, instead of looking for percentages, we want to know the number of people. Well, it's a very similar study, so we can set up a very similar chart. Okay, set up a column for the operating systems. Still have the same 3. Windows, Mac, and Android. And we're still talking about the same measures. Okay, ultimately, we want the number of people that chose each operating system. So ultimately, this is what we're looking for. This is going to be our final answer right here. Okay, but in order to get there, we're going to need the decimal, and we'll use the given percent. So looking at that story, what percent prefer Windows? From that story, Kieran? 55%. What percent chose Mac? Still you. 30%. And what percent prefer Android? 15%. Very good. Now, like we said, percents are great for conversation. Okay, to talk about, they're wonderful. They really help us get a grasp of how much of a group prefers something, or how many of a group fit into a particular category. But they're not so good for doing the math itself. Okay, what I'll need is to change each of those to decimals. So, let's change each of those to decimals. Brendan, how am I going to take 55% and turn it into a decimal? Divide it by 100. So, Brendan, if I take 55, divide it by 100, what do we get? Say that again? 0.55. Okay, Bailey, what about the 30%? 30 divided by 100. And what do we get? 0.3. Okay, how about 15%? How about 15%, Sid? Okay, and how did you get that? Do 15 divided by 100. And say that decimal again for me, please. 0.15. Remember, after the decimal point, we read one digit at a time, 0.15. Now, here's the real tough part. I need to go backwards. On this one, on the first example, I had the number of people that chose the operating system, and I wanted the percent. So I divided the number of people that chose it by the number of people that I asked, and that gave me the decimal. How can I take the decimal and go to the number of people? Eileen? Very good. We'll take the decimal probability, the decimal version of the percent, and we'll multiply it by the number of trials. So for Windows, we'll take that 0.55 and we'll multiply it by what? By 60. Because this time we asked 60 people. Okay, and Eileen, what did we get? About 33 people. Okay, so let's do the same thing for Mac. Mason, set that up for me, please. .3 times 60. And what does that give us? 18. Okay, what about Android? Set up Android for me, please, Ty. .15 times 60. I'm sorry? 9. So I have 33 people chose Mac. 33 people chose Windows. 18 people chose Mac. And 9 chose Android. Okay, take another time out. Okay, then, let's flip over to the back. Okay, and on the back we start talking about inferences. Now, we almost made inferences on that second example. What does inference mean? Anyone got an idea what inference means? Got an idea? It's kind of like a guess. Okay, it's kind of like a hypothesis, an educated guess. Okay, here's what we do. Here's what an inference basically says. An inference is when we use information from a sample to make a generalization about a population. Okay, like we said at the beginning, the example that we gave where I want to know what cell phone provider people use in the school. I don't have time to ask all 700 or 800 students, so what I'll do is I'll pick a sample. I'll pick a small group and I'll ask them. Then I'll take those percentages and I'll assume that they're true about the entire population. And I'll use those percentages to make those inferences about the whole population. So here's, in a nutshell, what we do. We take the number of students that chose each option, or the number of successes, divided by the number in the sample. Okay, and that gives us the decimal. That gives us the decimal version of that percent. Then what we'll do is we'll multiply that by the number of items in the population. Okay, and that will give us our inference. So, a survey asks 50 high school students what their favorite spring sport was. Track, baseball or softball, or golf. 32 chose baseball, softball. 10 chose track, and 8 chose golf. If there are 425 students in the high school, how many can be expected to prefer each spring sport? Well, here's what we need to notice. The survey asked 50 high school students. That's our sample. Our population is the 425 students. So, we've got another survey with some options. We can set up another table. Okay, and that table that we can set up will have a column, or excuse me, a row for each sport. So the sports we have are baseball, softball, track and field, and golf. Okay, we have the number from our sample, which we can use to find the decimal, and then ultimately we can make an inference about that population. Now, we're just about out of time here, so I want you to hang on to this chart, make sure you bring it back with you tomorrow, and we'll fill it out tomorrow.